All right, I asked you to do calcium to figure out where the electrons are located in calcium for homework. It was kind of not necessarily nice, but we had already done together sodium, so I figured just a few more. And I was going to cheat and do the first 11, and then I thought, oh, maybe some of you need to see it again, so I apologize if you don't. So remember, each electron is going to go to the lowest possible state it can. So when the first electron comes in, it's going to go into the n equals 1 because that's the lowest state. When n equals 1, L equals 0. And when L equals 0, ML has to equal 0. And then it has a choice of a positive 1/2 or a negative 1/2 spin. So let's say it picks a positive. The second electron comes along. It's also going to go into the n equals 1, and when n equals 1, L equals 0, and when L equals 0, ML equals 0, and its only choice is negative 1/2. So now when the third one comes, it cannot go into the n equals 1, because if it does, it's going to have the same four numbers as one of these two, right? And there's no such thing as L equals 1 in the n equals 1, because L can only equal 0. If L is equal to 0, ML equals 0. The next electron has to go to n equals 2. When n equals 2, though, L could equal 0 or 1. So it'll go to the 0 because it's the lower state. And when L equals 0, ML equals 0. And let's say it has positive 1/2 spin. Oh, so this third line is really because of Pauli's exclusion principle. Pauli's exclusion principle says you can't put another electron in this atom with either of those two sets. So the next guy, the only choice he has is to go to this next, to the n equals 2. Number 4 is also going to go to n equals 2, still in the L equals 0, still in the ML equals 0, this time negative 1/2. So now no more can go into the n equals 2, L equals 0 zone. The next one has to go to n equals 2, L equals 1. And when L equals 1, ML could equal 0, negative 1, or positive 1. Okay? And it doesn't really matter which one you start with here. So if we do 0, and let's say a positive 1/2 again. Now Hund's rule says when the ML ones fill, they're going to fill in such a way that each one of them, actually I think I want negative 1 up here, each one of the subshells will get a single electron before they start doubling up. Okay? So 1 will go into the negative 1, 1 will go into the 0, and 1 will go into the positive 1 before any will go in, a second one will go into any of them. And Hund's rule also says that when they do this, they always all go in with the same spin. Okay, so we're now at number 8. So number 8 is going to go into the n equals 2, L equals 1, ML equals negative 1, and now negative 1/2. And then the other two will fill up the 0 and the positive 1 with the negative 1/2 spins. Okay, so, and now no more can go into the n equals 2. There's no other options for these 4 quantum numbers than what we already have, so it needs to go to n equals 3. And when n equals 3, L can equal 0, 1, or 2. So starting with 0, when L equals 0, ML equals 0, and the spin positive 1/2. And then the next one, number 12, L equals 0, ML equals 0, negative 1/2. So L equals 0 and the n equals 3 is full. So the next guy has to go to L equals 1. And when L equals 1, ML can equal negative 1, ML can equal 0, and ML can equal positive 1/2 again. Okay, and remember, those 3 will fill before any of them will double up. And so now the next one will double up. It will go into the negative 1 with a negative 1/2 spin. Number 17 will go into the 0 with a negative 1/2 spin. And number 18 will go into the positive 1 with a negative 1/2 spin. So now, oh, I just realized I went one too big on you. So now the n equals 3, L equals 1 is full. So now one would think, and I'm going to say this for now, one would think it would then go to n equals 3, L equals 2, and then when L equals 2, ML could equal 2, 1, 0, negative 1, negative 2. So one would think that this would be negative 2 and positive 1/2, and one would think that this next one would be negative 1 and positive 1/2. And I'm going to leave these like this, but I'm going to put an asterisk here. We'll come back before the end of today's videos and talk about that asterisk, okay, because it doesn't quite go that way, and I'll explain why in a minute. All right, so here we have it, okay? Now, writing them out like this, you should be happy that I only gave you 20. Imagine if I had given you uranium, which is 94. This could get quite painful and use a lot of paper. And so there has to be an easier way to write these, okay? And so what they came up with were a few rules about shells and subshells. So they said electrons with the same number of n. So electrons with the same number of n. So these guys, these ones, and then all the threes. These are said to be in the same shell. Okay, so n is the same shell. And then they said, well, let's letter them. Let's say when n equals 1, that shell is called the K shell. And when n equals 2, that shell is called the L shell. And when n equals 3, that shell will be called the M shell, etc. Okay, so that was what they thought at first. So calling them shells, and then they decided to put letters where the numbers were. The second thing they said was electrons that have the same value of n and the same value of L are said to be in the same subshell. Okay, so this is a subshell. And this is a subshell. So same value of n and same value of L are said to be in the same subshell of a given shell. Okay, so these guys are the subshells. And they decided that they were going to give letters to the subshells. So they said when L is equal to 0, let's call that subshell S. Okay, so the S subshell. And the S stood for sharp. And they said, well, when L is equal to 1, let's call that subshell P. And P stood for principal. And when L equals 2, let's call that subshell D. And D stood for diffuse. And when L equals 3, they said let's call that subshell F, where F stands for fundamental. And when L equals 4, and as they were about to label it a letter, people were like, okay, wait, like this is getting way too confusing. There is no rhyme or reason with S, P, D, F. Like you can't just keep pricking like random letters. And they said, okay, then let's call this G subshell, and then we'll go from in alphabetical order from there.